We can consider a basic memory hierarchy to be consisting of the secondary memory, main memory, and the cache may be more than one level of cache. And in a multiprocessor system, instead of maintaining a single large cache for all the processors, each processor maintains its own separate local cache even at the same level. This can reduce the traffic to a common cache. Also, the size of the cache can be kept smaller, as a result access time can be higher. Thus, overall this performance can be improved. But this will create some data inconsistency issues related to the shared data which is present in the backstore, here the shared main memory. For example, let X be some shared data. Let three different processes are being executed on the three processors P1, P2 and P3. Suppose the processor P1 requested for the shared location X. Initially, it will be a cache miss in its local cache. Thus, the entire block containing X will be transferred from the main memory to its local cache. Now suppose P2 requested for the same shared memory location X. This will be a cache miss in its local cache. The block containing X will be transferred from the main memory to the local cache of the processor P2. Now suppose P1 executed a write operation and increment operation on X. So according to program order, the final value of X should be 1. But this will be reflected only in the local cache of the processor P1. This will not be reflected in the local cache of the processor P2 and also not in the shared main memory. So with this approach, there is chance for data inconsistency between the cache and the main memory and also between the local caches at the same level. Now suppose P2 executed a write increment operation on X. So according to program order, the final value of X should be 2, but here in the local cache of P2 it turned out to be 1. This happened because of the data inconsistency between the local caches of the processor. Now let P3 requested for the shared location X. The block containing X will be transferred to its local cache. Now P3 executed a write operation or an increment operation on X. The final value should be actually equal to 3, but here it turned out to be 1. This is because of the data inconsistency that was between the cache and the main memory. So this problem of data inconsistency, which occurs due to the lack of synchronization between the cache and the main memory and also between the local cache at the same level, is referred to as the cache coherence problem. To synchronize between the cache level and the main memory level, the cache level and the shared memory level, two approaches are used: write through and write back. And to synchronize between the local caches at the same level, two approaches are used: write update and write invalidate. There are different cache coherence protocols which uses the combination of these four approaches, which ensure that the global data is uniquely same on all the caches and the shared memory at a time by propagating the changes throughout the system in a timely fashion. We will discuss each of this in detail in the next video.